Okay, I promised you guys some walkthroughs of the review questions I posted. So that is what this is. I have not walked through any of these yet, but so I might mess up. Just bear with me a little bit. So first question is integrating 3x plus 5 dx. So again, I wanted to focus on substitution and integration on a bounded interval or closed interval or limits, I guess. So that's what the majority of these are going to be. So let's try and use integration for this. Once you get more comfortable with integration, you can kind of use your eye to see what to do, but we're going to use substitution to help us get on the right path. So first thing I want to do is see which of these has a higher order is the higher order of a polynomial. So you can see that this has an x, this does not have an x. So the thing we will sub is x plus 5. And the whole reason behind substitution is to simplify the integration down to just a variable. Once you just have a variable, it's a lot easier to integrate it, and then you can plug your, I guess, polynomial back in for the variable. So we're subbing in for the higher polynomial, so we're gonna see something like this to start with. But we need to also figure out what the derivative of u is, and that's just gonna be 1 plus 0 dx, right? X goes to 1, 5 goes to 0, so we're left with 1 dx. So this 3 is kind of here, as a constant. So I'm going to pull the 3 out like this, and now we're just left with times dx, du. Du just equals 1 dx, so dx equals du. Alright, so then I can pull out my constant due to the constant rule, and we see that this is just 1 over u du. And if you look at your nifty little guide of integration, you will see that this is ln of u plus c. And so now I will plug my u, or my polynomial, back in for u, 3 ln of x plus 5 plus c, and that is my answer. Okay, now let's do number 2. This one is a little more tricky, but it's the same type of concept. So we start with x squared, x cubed plus 5 to the 6 dx. And as you can see, this is a composite function. You have this function right here inside of this function. I guess, yeah, we'll just look at this, that function. So you have two functions, one is embedded in the other one. So again, I'm going to look at the polynomial with the highest order, which is highest degree, which is x cubed, because we have cube here. This is a 2, this is a 3, 3 is higher than 2, so we are going to sub for x cubed plus 5. Now I'll come back over here, and I will sub that, right? Du 3x squared dx. So you see that we have this x squared right here. So this becomes part of my dx, right? This is pretty close to this, but they don't have that 3 in front. So I have to multiply by a third, right? So 1/3 times 3x squared dx equals x squared dx, which is what I have here, x squared times dx. So I need that 1/3 out in front in order to actually have the same equation in terms of my u and du. So now I can pull the 1/3 out in front because it is a constant, u to the 6 du. And then this is just the general power rule, right? u6 plus 1, because we're going the opposite direction of a derivative, so we have to add 1 instead of subtract 1. And then divided by 6 plus 1 plus c. Just like that. And then we need to simplify this. 1/3 u to the 7th over 7 plus c, which is u to the 7 over 21 plus c. And now I can plug in my u and I will get my final answer. 21 plus c. Let me just check to see if that's the right answer. Yep, that is the right answer. Okay, let me do number 3 really quick. Number 3, so this is a trig function, and I can still use substitution. In fact, substitution is, I almost always use substitution when I'm dealing with trig functions. This one's pretty easy to see. You have sine of something, where this is another function. In this case, my function is x over 2. I will just sub u in for that function, which in this case is x over 2. So integrate sine u, and we see that du equals 1/2. So in order to get this to be exactly like this, I need to multiply this by 2. Again, this is because, dx. 2 times 1/2 dx equals dx. And since the dx up here is all by itself, I need to be able to get this out, which is why I have the 2. So those two are going to cancel. So come back over here, integrating sine of u. So I'm going to pull out the 2, integrate sine u du. And the integration for this, so in order to get to sine from deriving, we need a negative cosine times negative cosine u plus c. Now I will just sub my u back in and I will get the right answer. So I'm gonna bring the negative out here, negative 2 cosine x over 2 plus c. And that is my answer for number 3. All right, moving on to number 4, which is one of our bounded intervals. So we're going from 1 to 4, and this one we don't need to use substitution, right? Because this is just x to a certain exponent. So 1 to 4 of x to the 1/2 dx. Square root of x is the same, or we can write it as x to the 1/2. So we are going to integrate this x to the 1/2 plus 1 over 1/2 plus 1 plus c. And then I need, since we integrated it, but we still have this interval, I'm writing this little wall to indicate that I integrated this function up here. So let's simplify this down a little bit. X to the 3/2 over 3/2, which is plus c, 1 to 4. Simplify this even further. 2/3 times x to the 3/2 from 1 to 4. 4. Alright, so now we just start with plugging in. You got to start with the upper bound and then subtract the lower bound. So we'll just pull the 2/3 out and just do 4 3/2 minus 1 to the 3/2. Sorry, I'll put this in parentheses. So I can pull this 2/3 out because they both share it, so I just kind of factored it out. And so this will equal 4 cubed is going to be 16 times 4. I should use my calculator. Let's see here. That's on 4 to the 3 divided by 2. It's going to be 8. 8 minus 1, 2/3 times 7 equals 14/3. Great. Got the right answer. All right. Let's finish this off with number 5. I know this is a long video. You can skip around to find the walkthroughs if we need. Number 5. So this one, we have big old polynomial up top and a little polynomial. Oops, that's supposed to be an x in our denominator. So the trick here is you see a higher polynomial over a smaller polynomial. You should know that we are going to divide. So again, we're not substituting in this instance, but we do have a bounded interval here. So let us do some polynomial division. X squared plus 6x plus 5. Right, so it's the same thing. I just flipped it around because I like having my my degrees in descending order. So first step is, if I multiply this by x, I will get x squared plus 5x. So the key here is I want the first terms to match so that when I subtract, they cancel out. So that's why I chose x, because x times x equals x squared, and x squared minus x squared equals 0. And so 6x minus 5x is going to give me a positive x, and then I bring this 5 down, bring that 5 down, and so I'm just looking at the first term. What do I have to multiply x by to get x? And that is just 1. And coincidentally, 5 times 1 equals 5. Subtract this out. Conveniently, this is 0, which means I have no remainder, which means this will easily simplify into x plus 1 dx. So this is much easier to look at than this. this is also a lot easier to derive than that. So let's derive it really quick. So sum and difference rule. So I'm going to take one term at a time. I guess you could do it like this, if this is easier to look at or easier to understand why the sum and difference rule works. So x to the 1 plus 1 over 1 plus 1 plus 1 times x. We're just multiplying x to that. Plus c from 3 to 5. Simplify this down a little bit. X squared over 2 plus x plus c from 3 to 5. I'm going to come up here to finish this off. So we're going to start, we have to start with the upper bound first, so we're subtracting the lower bound from the upper bound. So we start with the upper bound. So 5 squared over 2 plus 5 minus, and again, the c's, you could put a plus c here, but c minus c is just 0. So I don't write the c's, but you can write them if you'd like. 3 squared over 2 plus 3. So 25 divided by 2 plus 5 minus 9 over 2 plus 3. We will get 16 over 2 plus 2. So I just did this and that, right? Which is 8 plus 2, which is 10. And I need to put equal signs in front of all these. And bada bing, bada boom, there's my answer. All right, so these are all the review questions fully walked through. If you have questions or if you'd like to see my work so you can kind of walk through it on your own, please just let me know and I will send those to you.